Welcome to Our Planet, Our Health, which features conversations with people from across Montana. I'm Rob Byron, an internal medicine specialist who practiced and took care of adults in southern Montana for many years. Most of our guests are healthcare professionals who've been working to protect health and human safety, to make people aware of how air pollution and climate change affects our health, and to address air pollution and the climate change it's causing. But health involves us all, not just healthcare professionals. With that in mind, some of our guests will be inspirational people who, while they may not be trained healthcare professionals, are experts and professionals in their own right, working to protect the health of others. Our guest today is one such person. Dr. Twila Moon is a glaciologist. She is Deputy Lead Scientist and Science Communication Liaison at the National Snow and Ice Data Center at the University of Colorado Boulder's Cooperative Institute for Research in Environmental Sciences. She is a world-renowned expert specializing in the connections across ice, climate, ocean, and ecosystems. She's a lead editor on the Arctic Report Card, serves on the U.S. National Academy's Polar Research Board, and has spearheaded efforts to improve knowledge exchange among scientists and between researchers and stakeholder communities. And of particular import, she specializes in bringing climate science knowledge to the business and philanthropic communities to drive impactful business solutions to address climate change. Twila, it's a pleasure and an honor to welcome you to our show.
Thank you so much. I'm really delighted to be here.
So, Twila, we'll talk about your credentials a little bit later. Let's give our audience a chance to get to know you. Where'd you grow up? And tell us a little bit about your childhood and your family.
Well, I grew up not so far. I grew up in Colorado Springs, Colorado, another kind of front range place. I actually lived in Billings for a couple years, and these two cities remind me a bit of each other. And I grew up there spending a lot of time outdoors. I lived next to a city park, so a lot of times outside running around barefoot, and for the most part, spring break was spent taking a road trip to go camping somewhere in the American Southwest or the Rocky Mountains. So lots of memories of frozen milk in your cereal on a cold spring morning, or taking binoculars. I was one of these kids, when given binoculars, I was gonna stare at the ants on the ground or the clouds in the sky or anything in between. And so my childhood was a lot of outdoor exploration and starting to get to be interested in science along with other topics too.
Wonderful, thank you for that. You gave us a little bit of an idea, but what are some of the things that your parents and other family members instilled in you as a child that have helped make you who you are today?
Well, interestingly, I actually didn't grow up in a particularly scientific family. I did have a grandfather who was a geologist and worked for Standard Oil, and I had another grandfather who was more in business management. My parents, my father owned a general contracting company that he started, and my mom did different secretarial work and things like that, but they were always interested in learning, being curious, asking questions. We always liked playing with language and sort of in that way needing to listen to what people were saying and interpret and play with it. But they were also really, in taking us outside and spending time outside, they were always interested in us asking questions. I have an older sister, about 8 years older, so a bit of a big difference between us. But they were always interested in us asking questions about where we were, learning about the people who use the landscape. We were often visiting state parks or national parks or monuments, things like that, stopping at roadside signs, and thinking about the people and the landscape and the plants and the animals and how they were all working together too, which I think gave me a lot of the interest that I still have in connecting dots between things and how things are really interconnected.
Well, thank you. And one thing you pointed out, which maybe isn't so uncommon in the West, but you grew up in a city but still have very strong connections to the land and the outdoors. I mean, maybe a little less common in some of our bigger coastal cities that people don't have those connections. So thank you for making that. So let's go on to your, I'll say your training, of which you have much, and you can fill us in on your education, and then we'll talk about more important things.
Yeah, well, I was always a good student. I always loved school. I loved learning. And I headed off to my college education at Stanford University in California. And I actually, my first year there, I really had a hard time finding people that I connected with well there. And I took the opportunity in the beginning of my sophomore year to do a study abroad program, actually with a totally different university. And that program was looking at ecosystems and ecology in Nepal. And we had the chance to trek from the lowlands of Nepal up into the highlands. And at the highest elevations we got to there, we hiked up into the Himalaya and we visited a glacier that was coming down off of Kanchenjunga Peak, which is the third highest mountain in the world. And it was summer, and we kind of got up onto this edge, and we were looking down at this big glacier coming through the valley, and you could hear it melting, you could hear rocks falling and water dripping. And at this time, I was really interested in kind of earth sciences writ large, but I hadn't found my particular interest. And in that moment, I really felt like this glacier, this ice was alive. I totally fell in love, and I went back to the university and I said, I want to be a glaciologist. Now, this was 25 years ago. Glaciology was not a job that people talked about. I'm sure people wondered, where in the world did you get this idea? There was no one at Stanford at that time studying ice, but luckily my supervisor said, all right, if you want to be a glaciologist, let's take lots of math and physics. Ice is actually a mineral, so you can study geology in rocks, and the same math and physics applies. And so I could dive in learning all about glaciology really simply because I fell in love with ice. And then I went on to do graduate work at the University of Washington, which at that time was one of the few places that had many people studying ice and snow and frozen landscapes. Nowadays, you can find glaciologists at many more places because we have discovered how quickly our frozen landscapes are changing because of our changing climate. So I really got to participate as one of those glaciologists discovering that the Greenland ice sheet, in my case, other glaciologists working on the Antarctic ice sheet, realizing that these landscapes could in fact change very quickly under time scales that people and politics care about.
Thank you. That's a good job. And you mentioned Greenland. Fill our audience in a little bit more about the work that you do, the actual research that you have done and continue to do, and put that in perspective also, if you can, with, well, you mentioned Antarctica. Help our audience understand that a little better.
Yeah, absolutely. I call these areas some of our big ice areas. So the Greenland ice sheet is a vast area of ice that covers the world's largest island. The Antarctic ice sheet, of course, covers a continent. And so it's almost difficult to imagine how much ice is in these locations in order to do this. The Greenland ice sheet reaches more than 2 miles thick in the interior of the ice. And it's hard to study areas of ice that are this big. And it was especially difficult before we had a lot of satellite data. So I was starting my research when we were starting to get more satellites in space looking at these areas. So I was beginning to look at measurements of how quickly the ice in Greenland is moving. In order for something to be a glacier or an ice sheet, the ice actually has to be in motion. That's part of the definition of it. So I started looking at how the ice was moving and discovering that the areas of the ice were really speeding up and moving much more quickly. I started looking at how water forms on the surface of the ice sheet. Some of that water actually drains through the ice to the interface between the ice and the rock below it. And that water can change how the motion of the ice behaves. And then I thought, you know, this ice is interesting, but it is part of a system. And as you kind of got an idea, I like thinking in systems. So I started working with colleagues who are oceanographers to understand how the ice and the ocean are influencing each other. Then I started working with colleagues who study polar bears and narwhal and understanding how these marine mammals were using the glacial environment. And of course, now I also spend a lot of time thinking about how these changes in these places that feel really far from us are actually really deeply connected to us and our everyday lives here very, very far from the Arctic.
Thank you again. And it's probably an unfair question, but can you tell us, condense 30 years of your work into a few minutes and tell us, what have you found and what do you see happening in particularly in Greenland and with the Greenland ice sheets?
Yes, well, for Greenland, one of the big things we see, of course, now is year after year ice loss. So with a big ice sheet, it's gaining a lot of snow in winter, and then it's losing snow and ice in summer. And ideally, you would be gaining as much snow in winter as you're losing in summer, and you're going to keep the same amount of ice in that ice sheet year after year. But we're warming our air, we're warming our ocean, and both of those things together mean that we're now consistently losing ice from the Greenland ice sheet. Now, when that ice is frozen in the ice sheet, it's held up on land and it's staying out of our oceans. But now, as we melt that ice, it's water that's being added to our oceans. So one of those big impact areas is increases in sea level rise in areas around the world. I'm also seeing how adding this cold, fresh water to the ocean is changing the fjords and the ecosystems nearby to Greenland. The Greenland economy, most of their exports are from their fishing economy. Most people in Greenland are really dependent on hunting and fishing for their food. You know, I think many Montanans can actually relate to that better than people might in some other states. And so they're seeing changes in the ecosystem because of the warming and because of this addition of cold, fresh water to their ocean. We also are understanding how putting this water into the ocean is changing how the ocean water itself moves around. And so how ocean water moves on our planet actually influences the climate and the weather that people experience. So for example, the way the Atlantic Ocean moves, it helps to bring kind of warm air up into northern Europe. But as we maybe change how that ocean is able to move because of the water we're putting into the ocean, those folks in Europe might start to experience both instances of extreme heat, but also surprising storms, as they may not get as much warm air being brought up to them by the ocean. So there are really wide-ranging influences from seeing how this ice sheet itself is changing, because one of its roles is kind of a global air conditioner, and another one of its roles is as a global water tower and keeping water frozen. So as we change those things, we really see impacts that cascade from things that people locally in Greenland are going to comment on to this kind of thing that would lead us here in Montana to comment on particularly hot weather or big heat waves, or the ability for our landscape to dry out more quickly than it used to.
So yeah, thank you. So you did a beautiful job of pointing out that it's not just about, say, water melting or a glacier melting. It is very much a domino effect, both locally and even globally. And you talked about it, but I'm going to emphasize it a little more, and that is, so the Greenland ice sheet thousands of miles away is melting. So what? Why do we care in Montana?
Yeah, I really understand this because you do think, wait, that's really far from me. I want to connect a couple different dots between us and Greenland and the Arctic. One of those dots has to do with the water and oceans. So counterintuitively, when we take ice from Greenland, melt it, and add it to the ocean, the biggest influence on sea levels is actually far from the Greenland ice sheet. I know it seems like the people in Greenland should be feeling the biggest effects, but it's actually exactly the opposite. And oceans don't rise equally all around the world, and a lot of US coasts are particularly vulnerable to rising sea levels, for example, in the Gulf Coast or along our eastern seaboard. And as you're raising that ocean water, some of those local health effects for people coastally can be, for example, getting salt in their groundwater, which can cause problems in, for example, septic systems or water wells that are having trouble keeping up with fresh water, and that water might become saltier, or it might cause flooding of septic systems, these sorts of things. But you'd still might say, well, but we're about as far from the ocean as you can get in North America. Not quite, but pretty darn close. So how is that connected? Well, the thing is that we've built a really interconnected economy and society. So when we think about, for example, goods, agricultural goods grown here in Montana, for example, a lot of those are exported. And often that's going to mean getting on a train and moving those goods out to our coasts and then putting them on ships. Well, that means that we depend on that coastal infrastructure, buildings and shipyards and things like that, to work well and to be in good shape for us to also use them to connect our goods to places across oceans. If we think, kind of leave aside the water for a moment and think about other changes happening in the Arctic and how they connect to us, another really close connection is that most of the Arctic, including the lands that are exposed around the edges of the Greenland ice sheet, are actually frozen lands, what we call permafrost. So it's land that's been frozen for many years, but as that air warms, that landscape starts to thaw. It's just like you're pulling a chicken out of your freezer and leaving it on the counter, right? It's not going to stay frozen. It's going to start to thaw. And as this frozen ground or permafrost thaws, it is also releasing heat-trapping gases. And those go up in the atmosphere. Our atmosphere is actually very well and quickly mixed. And so that is adding additional heat to the atmosphere from our human activities of warming the atmosphere. And it's this warm atmosphere around us that, for example, is giving us some very challenging wildfire conditions, that's allowing the development of drought to happen really quickly. So I think maybe people in Montana are noticing things seem that they can dry out more quickly than they used to. And we're also noticing how we can get really big amounts of rainfall in one kind of rain. That's because we have a warm atmosphere. It's hungry for moisture, so it's hungry to pull that moisture out of our plants and our landscape, and it also can hold on to a lot of moisture so it can drop big amounts of rainfall at once. So even these changes really far away in the Arctic are coming and influencing our day-to-day business activities, our day-to-day weather, and just, how we can move and work and live in our own landscape.
So thank you for that. But it sounds like, as you alluded to at the end, even though it's warming, we are seeing more extremes of weather, shall we say, whether it's precipitation. Does the same happen with snow? Even though it's warming, we see extreme snowfalls in certain places?
Yeah, you have that right, that we are seeing more extreme weather. And so we can no longer simply go back to our memory, well, this is kind of the worst thing we've experienced before, and that's what we're going to prepare for. Now we have to think about preparing for things we haven't experienced before. Snowfall is one of those things. So just like how we can have really big rain events in the summer or spring or fall, we can now see bigger snow events in winter because that our air around us can hold more water within it as it warms up, so we can get big snowfall. we also have this thing happening where the Arctic has generally been cold and we've been warmer down here in the mid-latitudes, and we've had these kind of jet stream winds that travel around our planet. And those have generally been pretty strong, and they help to keep cold air in the Arctic and keep warm air out of the Arctic. But these winds are not behaving in quite the same way as they have recently, and they're starting to become kind of wavy, we would call it. So you have a wavy jet stream. What that means is that this division between Arctic cold air and warmer air, where we are here in the lower 48, isn't kept as divided. And so we can have instances where that cold Arctic air is being swung down to where we live, and we have surprising cold events. And what might happen at the very same time is that you get a big wave pulling that cold air down, and then you have a wave coming up that's pulling warm air up. And so it also means that we might be experiencing surprising cold at the same time that a friend or relative, for example, who lives on the East Coast is experiencing surprisingly warm weather. And so not only are there some bigger extremes, but also we might be looking at people in other places and realizing that we're having really different experiences of weather at the same time too.
Well, thank you. Thank you for connecting those dots. So those systems are so big. Our climate systems, our water systems, our hydrological systems, the air, all of that, and very interrelated. What can we do about it?
Well, the good news is there is a lot that we can do, and also that it is also all connected. Sometimes I think when, I'm chatting about the Arctic or Greenland, people might become inspired or curious and think, well, but now does that mean I need to go to the Arctic or go to Greenland or do something there? But the really neat thing about our climate system is that it is deeply connected. This air around us that moves very quickly around the planet means that when you take local action, it has global influences. So you can look for things that are going to be related to climate action that are right in your own neighborhood. And in doing that, you can know that what you're doing locally is also going to have a positive influence for places far away, like Greenland. And so I really encourage people to think about, what are things, first off, who are the people you want to do things with? Because the number one thing in taking action about climate, whether you're working to reduce the pollution we're putting in the air, or you're working to build buildings that are more comfortable for us to be in when things are hot, the number one thing is don't do it by yourself. So think about who are the people that I want to be doing things with, maybe other people in my school or my family or my neighborhood or your own business. And then what are the kinds of topics that you're excited about? Maybe you love working on food, and so you want to get involved in reducing food waste, which is a great kind of action related to climate, and guess what, is going to help Greenland too. Or maybe you're really interested in local transportation and helping people find ways to not have to get in a car by themselves all of the time. Or maybe you're really interested in how do I help support communities being able to be more involved in having solar and have kind of a more energy independence, and that's something you're excited about. So the really neat thing here is that in order to make a difference for Greenland, in order to make a difference for our neighbors who live on the coasts, you don't have to go to those places. You don't have to take action in those places. You can work locally, and that is also going to make a positive influence for those people far away.
And one thing you said without really saying it is what it does take is for all of us to get involved or to engage in some way.
Absolutely. And one thing that I think is sometimes helpful for me thinking about how I'm going to get involved in things is to remember that there's different levels of involvement. So there might be something where you can think about where are the decisions that you get to lead and you get to make? Maybe you're a person who buys things for a business. And so in your decisions, you can decide, hey, I'm going to start to look into making decisions where I'm buying things that are going to have a more positive or at least a less damaging effect on our climate. And so you might be the leader in discovering what this action is, and you might be going out and looking for other people who have done something similar in other communities and learning from them. Or you might be in a space where you can see someone is leading and you like what they're thinking and you know that they need support. So you could come along and say, hey, I want to support you, I want to add to this. Or maybe there's something that a lot is happening, you don't have a lot of bandwidth in that topic, but you want to support it a little. Think about how can you be a follower that is adding bulk to that activity. So I sometimes like to think about, what's a little thing that I can change that is just going to help me be one of many, many, many people doing something. Like, for example, when I do my laundry, I'm going to do my laundry with a cold water setting. No one's looking over my shoulder. The way you do your laundry is not something that you're gonna lead on, but it's something that all of us together can do our wash on cold, and it's gonna make a difference. On the other hand, there are gonna be areas where I wanna be really vocal, sharing ideas with other people and kind of leading the way. So I think that too, there's many different levels of involvement, and you can be mindful of where you're going to put your efforts so that it doesn't become overwhelming, but also so that you can realize that you are part of many people taking on this work together.
Twila, thank you, and thank you for connecting what's happening in Greenland to what's happening in Montana and what we can do about it. We're getting close to running out of time. So you've been over a lot of ideas and given us a lot to think about. What are one or two things that you would like people to take away from our conversation today?
Well, I would really like people first to recognize that the climate is changing. It is caused by people, but to remember that the future is not set in stone. I think people sometimes get the misidea that we're already set and that there's nothing to be done. And so I think the very biggest takeaway is to remember that the future's not set in stone. There is a lot to be done, and by doing things locally and with other people and talking about those things that you're doing together, bringing more people on board, that's how we really move this in a positive direction for the climate, for health, for our families and neighbors.
So, Twila, thank you very much for sharing your thoughts with us today and for all the work that you do. And for our audience, would just remind you that Buildings Climate Week is coming up within a few weeks. You can check on the website, or you can check on Montana Health Professionals for Healthy Climate.org to look at the agenda. There's lots of activities for people with lots of different interests. Find something that is interesting to you and that might be passionate to you and get involved. Thank you for joining us today.